Greetings of the day, dear students. In this video, we are going to discuss about the nuclear power station layout. What are the different components we are having? What are the major components we are having? And what is the functionality of each and every component? All those things we are going to discuss in this video. If you observe in the layout of the nuclear power plant, we are going to have four major components. One is the nuclear reactor, another one is the heat exchanger, steam turbine and alternator. So what are the different components we are having again in nuclear reactor, like reactor core, fuel rods, moderator and also control rods, coolant and reflector. What are the different materials used in order to make up all those components, and what is the functionality of a heat exchanger, alternator. Along with that, we are also going to discuss about the advantages and disadvantages of a nuclear power plant in this video. Dear students, if you observe in our previous videos, we have discussed about the hydro power plant and thermal power plant, right? Here, with respect to the nuclear power station, the elements such as uranium-235 or thorium-232 will be undergo the nuclear fission process. Once this material have undergone nuclear fission, they are going to release enormous amount of heat. Now, this heat energy will be subjected to the heat exchanger, where this heat will be absorbed by the water and the water will be converted into the steam, and that steam will be at a high pressure and high temperature. Now this steam will run the steam turbine, which converts the steam energy into mechanical energy, and now this mechanical energy is going to drive the alternator, which will convert the mechanical energy into electrical energy. So this is the basic principle of operation in a nuclear power station. First, the nuclear fuel will undergo fission reaction. Because of that, enormous amount of heat is released. That heat will be given to the water, and the water will be converted to the steam, and that steam will be given to the turbine, and we used to get the mechanical output, and that mechanical output will be given to the alternator, which will convert the mechanical energy into electrical energy. Dear students, coming to its advantages, compared to the thermal power plant which runs on the coal or oil or gas, it is going to require less amount of fuel is required. It is also going to occupy the less space, and also the running charges, while operating the plant, the running charges will be low. And also it is more economical for the production of the bulk power. It can be located nearer to the load center, where there is the electrical load demand or electrical load requirement is there, instead of constructing the just like hydro power plant, which is to be constructed where the reservoir possibility is there, which will be generally far away from the load centers. But whereas this nuclear power plants can be located nearer to the load centers. And another advantage is the availability of the nuclear fuel is high, right? And also by using this nuclear power plant, another fuels like coal or oil can be conserved, or they can be saved, and those coal or oil can be used for some other applications, right? But whereas we are also going to have some disadvantages, like the capital cost of the plant will be very high, and more amount of technical knowledge is required in order to operate or maintain this plant, and also while commissioning this plant, erecting the plant, and while operating and maintaining the plant, more amount of skilled labor or skilled technical knowledge persons are required. And also the fuel, the nuclear fuel is very expensive, right? And another drawback is nuclear power plants cannot respond to the load fluctuations efficiently, right? And also disposal of the products after its disposal of the waste is a big problem. So these are the drawbacks we are having. Dear students, coming to its layout, if you observe, as I have told you, 4 major components are required. One is the nuclear reactor, and another one is the heat exchanger, turbine and alternator. In nuclear reactor, the nuclear fission process will take place, where the nuclear fuel will undergo nuclear fission. Because of that, high amount or enormous amount of heat will be released. Now in the heat exchanger tubes, this heat will be absorbed by the coolant materials, and the water will be converted, or coolant will be converted to the steam. Now with the help of control of the steam valve, the steam will be given to the turbine. Now the turbine gives you the mechanical output, and the mechanical output is given to the alternator, and from the alternator we are going to get the electrical output. Steam, after having done its useful work, that steam is again to be converted back to the water. That will be done with the help of a condenser, which will convert that steam into water. During that process, it is going to make use of the cooling tower. Once it is converted into the water, again this water will be fed back with the help of feed water pump into the heat exchanger. Dear students, with respect to the nuclear reactor, again if you observe, some major components will be there in the nuclear reactor, mainly the coolant, the fuel you are going to use, and the control rods, moderator, and neutron detector, reflectors, and the shielding cover. All these are the major components in a nuclear reactor, generally which will be a cylindrical shaped steel pressure vessel, and in that vessel only the nuclear fission reaction is going to take place. In the nuclear reactor, nuclear fission reaction is going to take place. Obviously, the reactor core, it is going to contain the number of fuel rods. And these fuel rods are to be cladded with aluminum or stainless steel, zirconium materials in order to reduce the oxidation of the uranium. Now the fuel rods, which are will be made up of natural or enriched uranium, and they will be shaped into the form of the rods which will be located in the reactor, and those fuel rods are going to undergo the nuclear fission reaction. Coming to the function of the moderator, it is going to slow down the neutrons which we have obtained due to the nuclear fission process, which will be moving with high velocity. Those high velocity neutrons are to be slowed down using the moderator. Now, before slowing down, these neutrons will be at high velocity of about 1.5 into 10 to the power of 7 meters per second, and those neutrons are known as fast neutrons, and these neutrons are going to collide with the moderator nuclei, and there they are going to lose the energy. In such a manner, the neutrons will be slowed down to the less velocity. Now, in order to make or achieve all these things, the moderator should be having low neutron absorbing property, high scattering cross section, and also it should be inexpensive and chemically inert. Most commonly used materials for as a moderator will be graphite, ordinary water, heavy water, and beryllium are the materials commonly used as a moderator. The function of moderator is to slow down the fast moving neutrons. Fast moving neutrons are to be slowed down that can be achieved with the help of the moderator. Coming to the control rods, its function is to control the rate of fission reaction by absorbing some of the thermal neutrons. So in order to maintain the chain reaction, or in order to maintain the steady rate of fission reaction during the operation of the reactor, or in order to stop the plant during any emergency condition, and in order to prevent the destruction of the reactor or the melting of the fuel rods or disintegration of the coolant, right, these control rods are required. So the functionality is to control the chain reaction, or to maintain the chain reaction, to maintain the steady rate of fission reaction, and also to prevent the destruction of the reactor. For all those things, these control rods are required. So dear students, the most commonly used material for control rods are boron, cadmium and hafnium are used for control rods. Coming to the coolant, it is going to transfer the heat generated in the reactor to the heat exchanger. The purpose of coolant is to transfer the heat generated in the reactor to the heat exchanger. And also, in order to keep the interiors of the reactor at a desired temperature, this coolant is required. And the most commonly used materials are, if it is a gaseous type coolant, we have to use air or carbon dioxide, hydrogen and helium will be used as a coolant materials. If it is liquid material, if lightly doped or heavy water will be used as a coolant. And if it is liquid metals, molten sodium, lithium and potassium are to be used as a coolant materials. Coming to the good properties of a good coolant, they should not absorb neutrons. They should be having non-corrosive nature, non-oxidizing nature, non-toxic nature, and they should be having good heat transfer capability. Now the another component is the reflector, which bounce back most of the escaped neutrons into the reactor during the process of nuclear fission. If some neutrons are going to escape, those are to be bounced back, right, into the reactor core. So this reflector, the good properties of the reflector are to be good neutron scattering property and the small tendency to absorb the neutrons, right, and also gets heated due to the collision of neutrons with its atoms. Therefore its cooling is essential for a reflector. All those things are to be maintained. Coming to the materials, the same materials we used for moderator, like the materials used for moderator like ordinary water, heavy water, beryllium and graphite are to be used for reflector. Coming to the shielding, it gives the protection from the deadly alpha, beta and gamma rays and neutrons which are released from the fission process. So if this shielding is not there, these particles are going to get escaped into the atmosphere and it leads to the harmful radiation and lot of problems to the skins and all those things will happen. So in order to make this protection, we need the shielding, and it will be made up of concrete or concrete with the boron compounds and iron. The shielding material will be made up of. Of course, the reactor vessel, now which is going to enclose all these components, will be enclosed in a reactor vessel, and it is going to enclose the reactor core and reflector and the shielding materials, and it is a strong walled container, right, and it has to withstand high pressures. It has to withstand the high pressures, and it is going to have entrance and exit of the coolant flow and also holes at the top of the vessel for the control rod's operation. It will be provided with the holes at the top in order to make the provision for the control rods. Clear? So this is what all about the nuclear reactor. One of the major component of the nuclear power plant layout is completed. So out of 4 major components, nuclear reactor, heat exchanger, steam turbine and alternator, the nuclear reactor part is completed. Dear students, the next major component is the heat exchanger. In this heat exchanger, the heat will be carried by the coolant and will be dissipated in the water. Now the water will be converted into the high pressure steam. The water will be converted to the high pressure steam. After releasing heat in water, the coolant will come back to the reactor by means of the cooling circulating pump. By means of the cooling circulating pump, again the coolant is going to come back to the reactor. So its main function is to extract the heat from the reactor and pass it to the water, dissipate it to the water and convert the water into the steam. Now this steam will be at high pressure and temperatures, right? Now that steam will be used or given to the steam turbine to get the mechanical output. Dear students, the function of the steam turbine will be same as in a coal power plant, or if you have observed the thermal power plant, in there also we have the steam turbine which is converting the steam which is going to give the mechanical energy as the output. Here the steam is going to drive the turbine in such a way to produce the mechanical energy. Once the steam have done its useful work, the steam is to be again converted back to the water. Now that steam is to be called as exhaust steam. That exhaust steam will be given to the condenser, the steam condenser, which it will condense the steam into water. Once that exhaust steam is removed, then only the new steam can be entered. The provision is to be made for the new steam to enter into the steam turbine. For that sake, the steam after having done its useful work, it is to be let out. Right? Yeah. Now the alternator which is coupled to the turbine, right? It is going to rotate and it is going to generate the electrical power that is required for the electrical utilization. Once we got the electrical power, which will be at low voltage, and high current rating. Now this voltage is to be stepped up to the higher voltage levels and lower current ratings in order to reduce the transmission losses. This generated power voltage will be stepped up with the help of a step up transformer, and it will be coupled and it will be injected into the power will be injected into the bus bar via isolator and circuit breakers and again an isolator, and finally it will be given to the transmission lines, and through the help of towers it is going to travel the long distances, right, with higher voltages and lower current ratings in order to reduce the transmission losses. So this is what all about the nuclear power plant. Dear students, I repeat again, if this question is asked in an exam, right, you have to highlight this figure, you have to write or specify the components present in its layout, and you have to explain the functionality of each and every component, and you have to highlight the 4 major components like nuclear reactor, heat exchanger, steam turbine and alternator, right? So this is what all about the nuclear power plant. Thank you.